that's going to be just 3e to the x, because e to the x differentiates to e to the x. So 3 lots of it is going to be 3 lots of it, minus a half lots of ln of x differentiates to 1 over x, and then the minus 2 differentiates to 0. And then just to simplify this fraction, we end up with 3e to the x minus 1 over 2x. For people who are, well, for anyone actually, real life or not, does it make sense? Well, did you get it? You got it. The curve of equation, so next part, the curve of equation y equals f of x has a turning point at p. The x coordinate of p is alpha. Show that alpha equals a 6th e to the power of minus alpha. So it's weird because you've got alpha equals something else with alpha, but we've just got to rearrange what we have to make this equal to what they're asking us to show.
Okay, so 3e to the power of x. These are great skills.
So you've got...
So 3e to the power of... Wow, how did you do that? Minus 1 over 2x equals 0. And then what you do is, you know that you have to rearrange it to figure out what x is.
Mm-hmm.
Well, in this term it's a, so just replace all the x's with a's. So 3e to the power of a is equal to alpha. 1 minus 2 alpha equals 0. And then the first step you can do is bring over the 1 over 2 alpha. So 3e to the power of alpha is 1 over 2 alpha. And then what I did was, with a little bit of help from the amazing teacher, Mr. Kuma, times everything by e to the power of minus alpha, because using indice rules, e to the power of alpha times e to the power of minus alpha gives you 1. And then you can also rearrange it so that 1 over 2x is 2x to the power of minus 1, just because it's a bit easier.
Mm-hmm.
I mean, you guys have that very soon. And then I just divided it by 3, because if you remember, 3 was part of a multiplication, so it's not just a number you minus it by. So 1 over 6x is equal to 1 over 6x e to the power of, not x, 1 over 6 alpha e to the power of alpha is equal to a.
Okay, so we'll do one thing at a time. So if we divide both sides by 3, that gives us 1 equals 1 over 6 alpha e to the power of minus alpha. And then multiplying both sides by alpha, we get alpha on the left-hand side equals a 6th e to the power of minus alpha.
Yeah.
And that's that part shown. For those, well, for everyone, does that make sense?
Sir?
Yes.
Sorry, basically my internet literally cut out for that question, and I'm really sorry. Do you mind just telling, so you equal it to 0 because you find the gradient, right?
Because it's a starting point and the gradient is equal to 0.
Okay, so, wait, so you need to find when the answer equals 0?
Yes.
Okay, thank you.
That's all right.
Sir.
Yeah.
You know, for that question, if I subbed in A into where X is that okay as well?
If you did what, sorry?
If I put A as X, like if I subbed the A as the X, basically.
Yeah, that's what you are supposed to do.
Oh.
Yeah. That's what I did. Those are alphas in the next lines.
Oh, I thought those are X's. Oh,
yeah, no, they're alphas.
Oh, okay.
Yeah. So it's not an A, it's an alpha.
Oh, wait, so what's the difference? It's not drawn as an A, it's like a...
It's an alpha. I mean, so I kind of make it look like half an infinity symbol kind of thing.
Okay.
Yeah.
Okay.
Or like a fish, yeah. Or like a fish. That's how you know a mathematician. Half an infinity. Yes. And that's still infinity, isn't it? Oh, yes. Like a fish. Like the proportional sign. Yeah. Annika, Megan, Scarlett, Georgie, does it make sense to you?
Yes.
100%?
Yes. No, I just did it.
Okay, cool. Another question?
Yeah, I was wondering, how do you get, why is it then equal instead of 1 equaling 1 over 6 alpha e or whatever, it then equals.
Sorry.
Why is it that when it equals it doesn't equal 1, or 1 doesn't equal whatever that is, and then it changes to alpha equaling?
Because I'm from the 1 equals line to the alpha equals line, I made it equal. God, that doesn't make sense. I multiplied both sides by alpha.
Yeah. Okay. Yeah.
Yeah. Cool. Okay. So part C then. Calculate the values of x1, x2, x3, and x4, giving your answers to 4 decimal places. So that's using the iterative formula. This is something that you would have done at GCSE a while ago, admittedly. But we've been told to take x0 equals 1. So x1 is going to be equal to a 6th e to the power of minus 1. And that's going to be using a calculator. 1 equals a 6th e to the power of minus. So this is just a case of putting it in a calculator. 0.0613. Oh, yeah, to 4 decimal places. And then x2, doing the same thing, just putting it, substituting it in, gives you 0.1568 to 4 decimal places. x3, again doing the same thing, gives you 0.1425 to 4 decimal places. And x4 to 4 decimal places gives you 0.1445.
So can I ask a question?
Yes.
I might have missed it because these people are just getting this. But what do you substitute into the x?
You substitute in x equals 1 for the first value.
Is that always?
Not always, it's because the question says what to substitute. x0 is what we start with.
And then what would you do for x2?
You substitute x1. So the answer that you get here, that goes back in the equation.
Okay. Yeah, I got that.
Cool.
Wait, what did x do?
So for the next part of the question, part D, by considering the change of sign of f prime of x in a suitable interval, prove that alpha equals 0.1443. Prove that it equals that to 4 decimal places. Whoever typed in the chat, I cannot see the chat at all. Could someone vocalize what was said?
Sorry, I was just a bit confused on the previous question.
Which one?
On the third line.
Yeah.
Because you did E alpha and you did 3E alpha divided by E alpha, right?
Yeah.
So why did you times it on the next line?
It sends e to the minus alpha. So you can either divide it to the alpha is the same thing as multiplying by e to the minus alpha.
Okay, sorry. Didn't see that. Okay, thank you.
So there's that. Cool. With part D, by considering the change of sign. So with a change of sign, what we need to do is take our iterative formula, which is alpha equals a 6th e to the minus alpha, and make it all equal to 0. So I'm going to write it like this. Alpha minus a 6th e to the minus alpha is equal to 0. Now I'm going to sub, which we're proving that alpha is 0.1443 correct to 4 decimal places. This is kind of a bounds question where we want to sub the lower bound and the upper bound. If this is 0.1443 to 4 decimal places, then the upper bound of this would be 0.14435. So, yeah.
I remember being told that if a question asks for you to prove something, you can't use the actual number.
For this, we're not using number.
No, No, but I'm saying you've got given a equals 0.1443.
Mm-hmm.
I've always been told that when you have a proof, you can't actually use any of the data inside.
So when we're considering the change of sign, what we can do is find a value substitute a value that's slightly bigger than this, smaller than this, and showing that you go slightly bigger than the answer, slightly smaller than the answer, and therefore the answer must be somewhere in between.
Okay.
Again, this is one of those topics where we will cover it in more depth as we meet it properly. So let's call this star. So we're going to sub 0.14435, the upper bound, into the star. Pardon?
Does this come with the marks?
Annoyingly, it doesn't, but I plan to make videos on this anyway, so it's all good. So when you substitute that in, you get 0.14435. You get answer minus a sixth of e to the minus answer. So that gives you, oh my God, a really small number, like roughly 8.58766 times 10 to the minus 5. So you get a really small answer. Then what we're also going to do is substitute. What we're going to substitute? Alpha equals the lower bound, which is going to be 0.14425. And then that's going to give us and that's going to give you minus 2.855 ... times 10 to the minus 5. So what's ended up happening is, because we've got this equation equals 0, we substituted in the upper bound, and that gave us a positive answer. We substituted in the lower bound, which gave us a negative answer. So the sign change implies that there is a root in between 0.14425 and 0.14435. And in particular, that if that root is in between those to 4 decimal places, 100% it has to equal 0.1443. That last part is a bit of a wordy one, but are there any questions about it or any other part of the question?
Wait, so because there's a root change, I mean a sign change, sorry, it means, so what does it mean, like the answer has to be between the two values, or it just means?
Yeah, it means exactly that.
Okay.
So that's why I wrote there a root in between 0.14425, 0.14435.
Okay. Sir.
Yeah.
So I'm a bit confused about. Okay, so first of all, why are there only why is it 1 to 4?
Why is it 1 to 4? Did you say?
Yeah.
What do you mean 1 to 4?
Like x1, x2, x3, x4.
Oh, just because the question asked only for those. That's all question dependent. As in, because the question says calculate the values of x1, x2, x3, x4.
Oh, sorry, yeah. Oh,
yeah.
I just read it.
So we just have to go with what the question says.
Which one is 1.4435 though?
So that's with the next part D, where they've said we want to show that alpha is equal to 0.1443 to 4 decimal places. So.
Oh, the line is the different question.
Yeah. No. That line is a different question. That's for the. So you see where I separated it with the blue line?
Mm-hmm.
That underneath that blue line is all the last part.
Okay. Thank you.
So that's part D. And that's part C. And then that's part B. And then that's part A. Any questions there? Any other questions? Cool. Okay. Second, the next question then that we'll do is this one here.
Yeah, go through, please.
Okay, so I noticed that people here, they were sort of pondering about how to differentiate a third x. How to differentiate ln of a third x. It's a chain rule question, but you could also, you could also go about it by splitting up the ln into ln of a third, as one person suggested, plus ln of x, which personally I think is nicer because then there's no chain rules to have to deal with. But for the sake of chain rule, let's practice it doing this chain rule. So let u equal. Oh, sorry, you guys can't see, can you? Thank you. Let u equal a third x. So then y equals ln of u. Then we have du dx is equal to a third. And then we have that dy by du is equal to 1 over u. Dy dx is equal to dy du times du dx. Dy du was 1 over u. Du dx was a third. U was equal to a third x. So 1 over a third x multiplied by a third. And that the thirds cancel, so you get 1 over x. So that's the differential bit. Okay, and then it says the x coordinate of P is 3. Usually with this, you kind of want to work out the y coordinate as well. So the y coordinate is going to be 0. So now, what else do we need to know? Okay, dy dx is equal to 1 over x. At x equals 3, dy dx is equal to 1 over 3. So therefore, just to make space, the gradient of the normal is equal to -3. And then we can apply y equals mx plus c. So y equals -3x plus c. It goes through the coordinate, because now we know the y coordinate is 0. Our coordinate is 3, 0. So we know our line goes through the point 3, 0. So we have 0 equals -3 times 3 plus c, giving us that c must be equal to 9. So we have y equals -3x plus 9. And that is our equation.